lecture slides. We're going to finish up talking about the introduction to organic compounds as well as alkanes. So last time we finished up with some of the cycloalkanes and the shapes of them. This video will primarily be dealing with the physical properties of them, of alkanes, as well as some reactions that we see occur with them. So typically alkanes are odorless compounds. They're going to be nonpolar. Think about it. Alkanes are just hydrogen and carbon. We know that hydrogen-carbon bonds and carbon-carbon bonds, these are both nonpolar. So it would make sense that the overall molecule would be nonpolar. This means that they won't dissolve in water. Water is polar. Alkanes are nonpolar, which means we can say that alkanes are what we call hydrophobic, which means they're afraid of water, or basically that they're not soluble in water. They will also be less dense than water, which means they'll float on top of the water. Here's an example for you of a large aliphatic chain. Here is a fat. Palmitic acid is one of the fats that we will be talking about when we get to our biochemistry. But I'm focusing right now on the blue portion, which is an alkane, a very long alkane chain that is nonpolar. This is very, very hydrophobic, therefore very, very insoluble in water, even though it has this tiny group over here, and you may be like, oh, polar, polar, polar. Yes, but because of how big this chain is, this polarity doesn't really stand a chance in helping to be very soluble. So straight chain alkanes form what we call homologous series. Basically this means they function as a class, but they differ in how many CH2 groups they have. So again, we know that CH3, let's pretend over here if this wasn't, this was just an alkane and not this acid, and CH3 over here, we would end up having just differences in how many CH2s are in the middle. The physical and chemical properties that make up these series are closely related and they differ in a systematic way. What we mean to say is how many CH2 groups we have, how big our chain of carbons is, will tell us in a predictable way the differences that will occur between them. So here we go methane through decane. So 1 carbon long versus 10 carbons long. And we can look at their melting points, boiling points, and densities. And we can see as we go from 1 carbon to 10 carbons that the melting point increases. Now it's hard to see this kind of here because they're all negative, but negative 182 degrees Celsius is much, much colder than negative 29 degrees Celsius. So the point at which these melt is increasing. We can see it also in the boiling point and in their densities. So think about this in terms of our inter-ER molecular forces. This compound down here has a whole lot more London dispersion forces occurring than this compound up here. And that's how we're seeing these differences. So if you need to go back and review Unit 1 with our inter-ER molecular forces, I strongly encourage you to do so. You will be expected to make comments on why certain organic compounds have certain boiling points versus others. So here's just kind of a visual representation of that. This is the number of carbon atoms. So methane, ethane, propane, butane, pentane, here's decane, and then we're going on and on and on and on from there. So all the way up to 16 carbons in the chain. Here are their boiling points. We can see as we add more carbons that we're getting higher and higher and higher boiling points. We can also see that there's a distinction. Here's room temperature, which means up until we hit about butane, we are a gas at room temperature. And then around 5 carbons and up, we will be liquids at room temperature. So I'll give you a moment to answer this question. Right? We know that alkanes, A and E, are all hydrocarbons, which means they're nonpolar, which means they won't be soluble in water. Which of the following alkanes is the highest boiling point? Octane. Out of all these, this is the highest number of carbons in the chain, which means that will be the biggest, which it would have the highest melting point, or excuse me, boiling point. The last topic that we're going to cover in this chapter are alkane reactions. We're going to start off simple. Alkanes are very, very simple compounds. They don't have a lot of reactions to them. As we move forward in our functional groups, as we go through these chapters, we'll have a lot more reactions to learn. The one that we're going to cover in this chapter is alkanes are combustible. So when we have a combustion reaction, think back to our Unit 1, or Unit 2, excuse me, when we were talking about different types of reactions. One of them is combustions, which is going to be a hydrocarbon plus oxygen, always yielding CO2 and water. It's always going to be that. Now, obviously, the ratios of everything might have to change, where you would have to balance a chemical reaction, but for the most part, that is the recipe for these reactions. Some sort of alkane, hydrocarbon, plus oxygen will yield CO2 and water. Now, sometimes we have incomplete combustion, where we don't have enough oxygen present. So here is our, our hydrocarbon, in this case methane, plus some oxygen yields CO2 and water. But we'll have some leftover material, and we get some carbon as like a soot. Sometimes what can end up happening is we can also produce carbon monoxide. So this is a dangerous reaction. We know carbon monoxide is poisonous. When we get to our biochemistry unit, we will discuss why that is. But this is an undesirable compound, this incomplete combustion. Not only are we getting carbon deposits, or like soot, which can be dangerous to like your chimney or like an engine, but we're also producing carbon monoxide, which is poisonous. So can you answer this question? The complete combustion of the molecule below produces which of the following? So to answer this one properly, you're going to have to figure out the formula of this reaction, then write out the equation, the chemical reaction, and balance it. So I would encourage you to pause the video here and to try that. We will produce 9 molecules of carbon dioxide. That is the end of Chapter 11. At this point, you should be working on your homeworks and doing the worksheets that are provided in the Unit 3 study guide section in the extra help. I encourage you to email me with questions and to set up time for office hours if you have anything you'd like to discuss.